Then, bear with my spellings because I typed it just now. Demonstration of complete data analysis will be there. Then we will start actual learning of R programming. Why R programming shall be the first question. Whenever we need to travel a short distance, we use bicycle. If you are asked to travel about 10 kilometers or 20 kilometers, you will prefer a bike. And when you are asked to travel hundreds of kilometers, you will prefer a car. If you can afford the car, you will prefer train because that is little comfortable option. Or if possible, you can go for flight also. Flight will take you to very long distances within very short time. You will save your time and you will save your labor. The same thing is with R also. R is just like a car. If you require it to work at very little higher efficiency, then you can use that as a supercar, which will run at very fast speeds. You can use that as a train to carry very large load. You can use that as flight to travel the distance in very short period of time. R is anything which you can make as per your requirement. Just like Lego bricks available. You can join all those bricks together as per your requirement and use those to make your work easy. It's a tool. It's a tool. Okay. Now, many softwares are there, other softwares which we use. One of that software is Excel. Many of you are very comfortable with Excel. This is just like Excel. This is not Excel. This is Open Office Calc, free version of Excel. Excel is not free. Most of us actually use pirated Excel version. Excel is not free. There is little cost associated with Excel. This Open Office is free one. But again, Open Office is not meant for very large data analysis or very efficient data analysis. It is just a spreadsheet program which will make your work easy by allowing you to interact with it using click-based interface like this. You can click on the cell and you can type in what you want there. It's easy to use, just like bicycle. For small work, these spreadsheet programs are good to use. Other programs which are available commercially, those programs are SPSS software. And that IBM software it's free for 3 days. Try free for 3 days, and then pricing is there. And that pricing is usually they don't give pricing here, but starting at USD 99 per month, 99 USD, 100 USD, it is 8,000 per month. SPSS. I don't know how many students can afford SPSS. Then SaaS is there. SaaS pricing models are there. And then where those pricings are there, that is 300 per month. Many of such commercial softwares are available at a cost. And those are affordable to very large corporations, to companies, to colleges, but colleges cannot afford that on all their computers. R is just free to use. You can download R programming, R Studio, both are free. You can download and install on any computer where you want to work. If you have purchased software like SPSS or SAS, you have to be there at the computer where that software is installed. If you want to do that at your home, And if software is not installed there, you have to purchase a license again. If you want to work whenever you are on vacation to any other place, there also, if you want to use that software, you have to purchase that again. Sometimes licenses are available that those licenses you can install on many systems. R is free. You can install on any computer which is available to you freely. And that's not difficult to install also. Initially, if you are not uh, good at installing the softwares, if you are handled the computers much, then it will pose some problems. But those problems are not that serious. Our installation is very easy. Okay. Initially, we'll see the strength of R. We'll go to the files which I shared with you, and all those files I prepared using R only. Those HTML files, instruction to install the software, introduction to R Studio and R Code HTML. All these files I made available to you. Next is experiment 1, that is growth curve experiment. Okay. A growth curve data is there, and that data I analyzed using R. I'll just download that and we'll open that as downloaded file. And this is the file for that. This is title. I prepared this file using R programming only. Experiment 1, growth curve experiment. This is the analysis which is done there. Growth model is fitted. Then values are calculated. That K is calculated. K is growth rate. N0 is initial number of cells calculated. K is actually capacity, not growth rate, 0.371 maximum which can be achieved. R is growth rate, 0.81. That is growth rate. And many such things you can calculate there very easily. Plot is there. You can see the plot. And this plot is almost publication ready one, where you can see that carrying capacity of this environment is 0.37. If you know these concepts K and R, K is the organism will try to grow to maximum capacity. This is the maximum number of cells, 0.37 ODU units, optical density units, this system can reach. 0.81 ODU per minute is the growth rate. That growth is taking place at that rate, time t, and many such things are there. Okay. This summary table for the data is also prepared. That summary table is for the model, and that how much K will be there, that 0.39 K is there, 0.34 to 0.45 is the 95% confidence interval. 96 values I studied because this is from 96 well plate experiment. 96 whales were studied for this culture. N0, initially the cell count was 0. Growth rate R 1.09, 0.94, 1.25 was the 95% confidence limit. That 95% I'm sure that my growth rate will be within this range, 0.94 to 1.25. Then generation time is there, 0.64. 95% I'm sure that my generation time will be there in 0.56 to 0.74. Okay. And this is median. You can see it as footnote, and here that one is given. Because all these values are median followed by interquartile range. And all these things you will learn as you go on learning the R program. We'll go to the next one. This is not much impressive one, but still that file shows that R can do some things very efficiently, and that we'll do as we go on in this session. That again, I will go back to my agenda. Initially, I will show you the strength of R. I will tell you why to learn R. R, if you are good at Excel, you'll find R difficult to learn because R is command interface. you'll have to type in code. You have to run that code, and then you will see the output. In Excel, you see the output on the screen directly. You do the task, you run that, and you see the output. You do see that in front of your eyes. In R, you have to type in the code. The click-based interface and icons are not available. And therefore, initially, R will be a little difficult to learn also. That I will show you using that paint. I will try to explain that this is graph, complexity of task, and then labor required. If you use Excel, then as complexity of task goes on increasing, the Excel will take much labor. If you use R programming, this red line is for Excel. I will write in there the legend for this Excel. And if I use R programming, then initially I require much labor for simple tasks. But as my task complexity goes on increasing, my labor will be much less. My efforts required, my time required, my cost required will be much less. For very complex works, Excel is almost ineffective for complex works. And for simpler works, R, you find it little difficult. But as you go on practicing R, as you go on learning R, things will become much easier for you. In Excel, you will not get report. You have to cut and paste your analysis in Word file. In R, you can directly convert that to Word. You can convert that to HTML. You can convert that to PDF. You can convert that even to PowerPoint presentation. I have prepared this presentation using R only. Now, I want this presentation to be in PowerPoint format. I will go there at my code and I will just do one thing here, one change, PowerPoint. And when I run that, it shall get converted to PowerPoint. On my system, that will be a little difficult. Hello? Somebody tried to speak something, or it may be accident. We will go back. This is my open office version of PowerPoint, where I converted this presentation, which was in R format, to a PowerPoint format. And here this workshop agenda is there. My name is there. Dates got added there. And here that installation, that spelling mistakes I can correct here. Installation, demonstration. And this is my presentation. That initially I will go for demonstration of strength of R, installation of R programming, installation of R Studio, demonstration of complete data analysis, and introduction to R programming. Now, if I want to prepare a tutorial out of it, I can prepare very easily that tutorial. I will just make that HTML document, and there I will run this. And I will get a nice HTML document for that. I'll just type in something here as a code, demonstration of strength of R. Somebody wants to join. Admit, yeah. I'm just demonstrating strength of R. This is HTML I created using the R program. Now I want to add my code there. Here, I will do one very little complicated task for Excel to do. That is, I will plot a survival curve of cancer patients. For that, I will type in the code. Don't bother initially about the code because you are new to this system. Hello. If you want to ask questions, you can ask questions. If you want to stop me in between, you can stop me in between. If you want to discuss some issues, we can do that. The issues shall be regarding this session only. And I again announce one thing. I usually prefer to start my session exactly on time. And therefore, it's my request to you people to join not at least, join 15 minutes before, at least 5 minutes before scheduled time, so that you will not lose the initial things which we discussed during the session. Now I'm just demonstrating the strength of R, and this is actually R Studio environment where I am working. I've deliberately kept the meeting window also open so that I can allow people to join. Initially, I can't be that lenient, but tomorrow I cannot assure you that I will allow after that 7:30, time 7:30. Tomorrow, not tomorrow, on Monday.
Sir,
Hello?
sir, this
Yeah.
app for
Little disturbance is there.
because my PC is not allowed to install me.
Software.
Yes.
Okay. We'll answer those. I will arrange a special session on preferably on Friday, tomorrow. Tomorrow at 7:30, I will help you, help all those who want help for installation. Many of you may get uh, success in installation. Might have got success in installation, many of you. But for those who find it difficult to install the software, I will help those by arranging a special session. Will that okay?
Okay, sir. Okay, fine. Thank you.
I will arrange that special session on the same link. This will be the link available to you all. You can, you have to join from the same link. Okay, okay. We'll move further. Now I'm showing you, demonstrating you strength of R. R is a programming language. Initially, you find it little difficult initially, but it's not at all difficult. Okay. As time goes on, within 20 or 30 minutes of doing R, you'll understand that it's not difficult. But you have to be passionate, you have to be motivated, and you have to be determined to learn R. If you are hesitant, then it will be difficult for you. You shall have honest need to learn the software. Then this software will be for you. I deal with that, I don't know. Okay. Here I want to demonstrate strength of R. I will show you how that survival curve and summary tables are prepared uh, in clinical sciences, health sciences, in bacteriology also, microbiology also. We can use this survival curve to show under what conditions those bacteria will survive better, or those bacteria will get killed better. Is there any difference of two drugs, effect of two drugs on the growth of those bacteria? You can study that using this. I will do that using the built-in data set. Many built-in data sets are there in R, so that you can learn using those as toy data sets. I'll have to keep on repeating to those who are joining little late that I'm just showing the strength of R. And after that, this will be this will be our agenda: demonstration of strength of R, installation of R programming, installation of R Studio. Then we'll go for demonstration of complete data analysis, then intro to R programming. Today's session will be for demonstrations. Okay. I will demonstrate installation of R also. I'll demonstrate installation of R Studio also, and I will demonstrate complete analysis also. Initially, just a glimpse of analysis. Okay. Library survival I will use. Another one is also this I will use. I want summary of the data which I am going to use. I want to see that summary. And here, this TBL summary is the function for that. And if you see, as I go on typing, it is helping me. I don't have to remember code. I just have to remember first 3 alphabets of the code, and R Studio will suggest me the code. And here in TBL summary, I will just put in name of the data set which I want to use. That cancer data set I want to use here. Cancer data set is available in R. Therefore, I don't have to import that. That importing of data also I will show you as we go on during this workshop. The TBL summary of cancer, I will run that, and that summary table is ready. Okay, this is summary table. Characteristic means variables. N is 228. 228 patients are observed in this study. Institute, that institutional ID is there. That 11 institutional ID, 11 institutes supplied those patients, provided those patients. One unknown is there that we don't know which institute gave us or sent that patient to us. Then time, 256 days is the median time for which those patients were studied. 256. That interquartile range, 25% were below 167, 25% were above 397, and 50% were in between. This is interquartile range. That is just to show spread of the data. Status, 1 is for no death and 2 is for death. Okay. 63 patients survived till end of the study. 165%. Excuse me for this. 165 patients died during the study. That is 72% patients died during the study. Cancer patients. Age of the patients was 63. Median age was 63. That interquartile range is 56 to 69. Then 1 is for male. 138 male were there. 61% male patients were there in this study. 2 patients were 90 patients were females. 39% females were there. Then this is actually scale to see how much movement is there, motility is there in that patient. Okay. That 63% patients were all good. They can move easily on their own. 133 patients were having little difficulty in movement. 50 patients, 22% patients have more difficulty in movement. 0.4% or only 1 patient is actually not moving. Then other scale is also there, that pH Karnofsky scale, that is for severity of that cancer. And as we go on the scale, 29% were 100% severe. 29 people, patients, 13% were 100%, and 6% were have very little severity of the cancer. Then other scale is there. Meal calories, 75 is the calories which those patients are taking in their meals. 975 calories, too less calorie. 2000 calorie is actually normal one. Some that 50% were taking 1,150 up to 1,150 calories. Okay. Some patients are taking more than that. Okay. But those some patients are just 25% of the study. Okay. 47 patients actually didn't reported how much calories those were taking. Weight loss, 7-pound weight loss is there. People experienced 7-pound weight loss, and that weight loss in 25% people actually observed 0 weight loss, 0-pound weight loss. Up to 50% observed weight loss to 16 pound. Okay. And 25% people observed weight loss more than 16. And 14 people actually didn't reported weight loss. That is the summary which I got without calculating anything. This summary is computed by the software and presented in a nice format to me. This summary I can incorporate in my report. Now I am preparing HTML document, and this document I will present to my agency, to my officers, and that this is the summary table. I will explain that summary. If they want me to present that in PowerPoint format, then just one line will help me to convert that to PowerPoint. I don't have to cut paste, and that is my time saving. And there I will become efficient, hardworking, intelligent employee. That the file is open. I'll have to close the file, and I will run that again. This file will be written then. This is actually code is getting compiled and code is getting converted to the PowerPoint format. And this is the PowerPoint format here. And actually that didn't got encoded here in the agenda because that HTML thing is there. And that HTML didn't got incorporated into PowerPoint. I don't want this to be PowerPoint now. I will go for HTML presentation. Not HTML presentation. IO slides underscore presentation and run that. It's getting converted. Just one line is sufficient. And if you don't remember that line, you can Google. Workshop agenda, this is HTML presentation. I will open in the browser. And as I click, that slide will open. This is the slide. I'll close this. Don't consider this. This is a little issue with R, that it is showing some messages and those messages are actually politically incorrect. But we are using a free software and everything is not that free. They will show you some messages. That is the messages by some protesters. They want to highlight the Uyghur Muslim problems. That IO slides presentation I got. Now I will convert this. Just go to another slide. I will prepare another slide. And that another slide will be survival curve. And you'll find that survival curve is also not that difficult to obtain. Very easily we will get. And even if that survival curve is alien to you, you'll understand. And if, unfortunately, that shall not be the case, if any of your relative has cancer, then you can go on net and try to find out survival curves for those patients. And you will find that the cancer is actually not that killing, and you'll get some good feeling, some solace that your relative, your patient will not die soon. I will just create the curve, survival curve, and all this will learn as we go. You all will learn as we go further. That model I want to create now, in the model, I will use this surfeit. Then time, status, and the cancer data. We'll run that. Model has been calculated. Summary we can see. I will not explain summary just now because that summary is little complicated for you to understand initially. Much numbers are there, and we don't have to do anything with these numbers. Let it be there. I will plot this mod now, and you can see the curve. Can you see the curve now? Hello?
Yes, sir.
Yes.
This is just beginning. This curve can be customized further. Now, if I want to see what is the time at which 60% of the population will die. Okay. And this is 0.6. This is hazard risk, actually, death risk. 0.6, 60% death risk is there. And that is around 250 to 300 days. 60% survival is up to this point. And beyond that, up to this point, almost 40% population will die up to this 300 up to 300 days. 60%, this is survival. On this curve axis, survival is there. And as we go further, that survival will go down. That is beyond 800 days, only 10% population will survive beyond 800 days. 25% population will survive up to 600 days. 600 days is almost 2 years. 800 days is almost 2.5 years. After these 2.5 years, all those patients studied here, most of those died. Only 10% survived beyond 1,000 days. This is the strength of R. Very efficiently, it gives me the information which I require. Now, I want to see the difference because of sex. That is, I will keep that sex, run that, and what I did there, here, I ran that summary plot. That it's showing me the summary, and this is the plot. We can't see the color here. But believe me, the upper line is for female. Female survival is much better as compared to males. Female survival is much better as compared to males. Okay. If I want it to be little pretty, I will use another facility to make it better. A beautiful plot I want. And there, mod, just this function is sufficient to give me a beautiful plot. Hello, can you see that?
Yes, sir.
This is saving your time. If you want to do this on Excel, you will require almost 1 hour to get that. Because in Excel, such facility is not available. You have to learn a lot. and then you will get success in getting such type of plots. In R, that is available. I want to add risk table. Add, will not use that mod. I forgot the code. Therefore, I took my cursor on this function and I'm seeing the code now. Risk table I want to add. That here that risk table is there. Risk table is equal to false. I want it to be true. Risk dot table, R has provided me the help. I will take that help and there I will put this true. Now you'll see a change in this table, in this plot. And here a little customization is required. Sex 1, 138 people were at risk times 0. Sex 2 means female, 90 patients were at risk. As we go to 250 days, 62 people were at risk, 62 males, 53 females were at risk, rest died. 20 were at risk, 500 days, 21 females were at risk, 750 days, 7 were at risk, 7 males, 3 females were at risk, and 1000 days, no female survived, only 2 males survived. Okay, 1000 days. And this is the curve for that. Okay. We can add some more information also. I will just see that because I don't remember how to add that information. I'll just take my cursor here and we'll try to see here, serve median line. Median line, median survival, 50% survival I want to see. That I will type in here, serve dot median line. And if you see here in the gray box, those values are also given. Include one of none, HV, H, and V. HV is for horizontal and vertical both. In inverted code, HV. Run that. Can you see the median survival? Hello?
Yes, sir, we can.
Those dotted lines are there. That for males, median survival is little beyond 250 days. And 50% survival for female is almost near 350 days or more than 350 days. 100 days difference is there in 50% survival. 50% females are surviving more as compared to males. A significant difference is there. If you want me to add p-value is actually strength of that observation that there is no difference in survival. P-value is the measure of that no difference in survival. I will try to see that probability of no difference, that p dot value, p-val, GG plot, p-val is equal to true. Run that. Okay. And here you can see the p-value. What is that p-value? 0.0013. That means that is only 0.13% probability of no difference. 0.13% probability of getting the data showing no difference. 0.13% is almost negligible. No difference is almost negligible, means there is significant difference in survival of male and female. Hello? Can you see that it is showing us some information?
Yes, sir.
Some good information. Okay. And that information is also, we can easily convert to report. And I think this is in format IO slide presentation. This summary, I will just suppress. and we will compile it again. And now I suppress the summary. Demonstration of strength of R. This is a survival curve. Actually, I tried to suppress that, but why it's there, I don't know. EBL summary. This summary is here. I will suppress that. Only the plot I want there. I'll compile it again. A little beyond this, because that is presentation and the slide is showing some more information also. Therefore, I will just convert that to document, document, sorry, and run that. And that's the beauty. We can get it in any format which is suitable for our work. Okay. That p-value is there. The median survival is also shown on the plot. Strata, sex 1, sex 2. Number at risk is also shown in proper format. Colors are also provided, lesion, everything. Okay. That cancer is myeloma, that is masked, and all those messages are there. I don't actually want those messages. Now, I want this analysis using a different data, that is colon. And colon data has these variables again, time, status, and sex. Colon cancer data. That cancer data was general cancer data, lung cancer data. This is colon cancer data. This is the plot for colon cancer, and you will see that this plot is little different. And there is no significant difference in death in males and female because of colon cancer. That p-value is 0.61, means 61% of the time we will see that there is no difference in male and female survival in colon cancer. And survival is much better as compared to 250 and 500 dose survival, median survival was there. Here that survival is beyond 2000 days. 2000 days is almost around 8 years. 7 to 8 years, that is. Less than 7 years. 365 days are there. That will be around 6 years. That survival, median survival for male. And median survival for female, that is going beyond that. But that is not statistically significant. This difference is appearing larger, but that is not statistically significant. Okay. Hello.
Yes, sir.
And this is the beauty. If you want to be a good researcher, a respectable researcher, then this will add to your skill sets. This skill shall be in your arsenal. Arsenal means the banancha bhata. Okay. If you practice this, people will start respecting you. People will start accepting you for good positions. Okay, you will be a good researcher if you know this. This is one thing, one strength of R. Okay. We'll just add to the strength of R in front of you. Another slide, strength of R. The code I will add there. That I want to see the relationship between variables of data iris. Iris is again a bundle data set, and just one line has given me the pairwise plot. Hello?
Yes, sir.
Now, if you see here, petal length and petal width have good positive correlation. Okay? Petal length and petal width has good positive correlation. And there is good correlation between sepal length and petal length also by this plot, where my cursor is moving. Okay. Little correlation is there between sepal length and sepal width. Little correlation is there. Okay. Now, we can see the strength of that correlation also. I'll just get the correlations or pairwise correlations. Iris. First 4 columns, numeric columns. The species column actually I don't want here because it is not numeric, it is categorical. You will understand all these things as we go further. We'll run that. Where I am? Corval. And I will run this. Can you see the correlations on the screen now? Hello?
Yes, sir. Yes, sir.
If you
Yes, sir.
see correlation for sepal length and petal length, sepal length and petal length, that correlation is 0.87, very high correlation. Petal width and sepal length, that is 0.81, very high correlation. These two variables are changing with each other. If you see here, that 96% or 0.96 correlation is there between petal length and petal width. If you want to see it as a plot, here the functions are, I'm just typing first 3 alphabets and I'm getting the functions. And there I will provide it with the value and will run that. Can you see the plot? This can be customized further. If you see scale of that color is also given. And wherever you see a dark point, very high correlation is there, almost 1. Sepal length 1, sepal width 1. And wherever darker color, that petal length is a very high correlation, petal width very high correlation. Very little correlation is there between sepal width and sepal length. These 2 points. And little correlation is there between petal length and sepal width, petal length and sepal width, petal width and sepal width. Little correlation is there. But petal length, petal width and sepal length have good degree of correlation. Hello, are you all there?
Yes,
Yes,
sir,
sir.
we are there.
A very,
Yes, sir.
very interesting software it is. And it is making your numbers very interesting. If you see the iris numbers, you'll find that that is very difficult to understand all these things. These are numbers of this one. The setosa. If I go further, you'll see setosa till 50, then versicolor will be there. But what to do of these numbers? If you don't see the values as some shapes, some figures, some colors, you will not understand those. Our eyes are not made up, have not evolved to see the numbers. Our eyes are evolved to see the shapes. And those shapes are actually making the difference. Those shapes are adding to our information. I'm doing a very intricate task now. I'm plotting a very colorful plot of iris data. Okay, iris data, I will explain a little about that data. That is iris 1. One researcher studied 50 flowers of iris species setosa, measured sepal length, sepal width, petal length, petal width of 50 flowers belonging to 50 different plants of variety setosa, 50 different flowers from 50 different plants of variety versicolor, and 50 flowers from variety virginica. And that information is provided to us using this iris data set. And I plotted the pairwise correlations between that. Can you see the plot now? Scatter plot is also there where you can see the correlation. You can see the distribution of sepal length, that most of those have sepal length 0.4. Very few have sepal length very high, larger sepal length. Here, the peaky distribution is there for sepal width. Here, bimodal distribution is there for petal length. Bimodal for petal width. Box plots are also shown. You can see the distribution is different. Distribution is different for these three species. For sepal length, distribution is different. For sepal width, distribution is different. For petal length, you can see that in variety Virginica, petal length is quite large. In variety Setosa, petal length is very small. The same thing for variety Setosa is for this one. And in variety Setosa, petal width is small. In variety versicolor and virginica, petal lengths are larger. These are iris flower. If you want to see the flowers, I'll show you the flowers and then you can appreciate the flowers. Okay, this is iris flower. And if I want to see iris flower, Setosa, versicolor, virginica, that these three varieties are there. Okay, Setosa, small sepals are there. Okay. Longer sepals are there, small petals are there. Okay. And the differences are there. Using these differences, we can classify these flowers. Someone wants to join? Okay, I'm allowing joining after that, much after that 7:30. We are there at the end of the session. Okay. And in next session, we'll actually start learning R. This is demonstration of R. Okay. A demonstration of strength of R. Someone is joining. Okay. And I want to see the colors of these three different species. Here, I want to see the colors of these three different species. Therefore, I will just change it a little. One code I will add. Color is equal to species. Color will be according to the species. It will take little time to compute that plot because much strong computation is going on. Many such subplots are there and it is showing me correlations. Okay, this is the density. This is Setosa, very small petal length, the sepal length, and the intermediate sepal lengths are here. You can see that in sepal width, there is not much difference in versicolor and virginica, but sepal width of Setosa tends to be little higher. Petal length of Setosa is very small as compared to these, but number of those is very high for certain values. Therefore, we see the peaky distribution. Same thing for petal width also. That these correlations are also there. Okay. Very high degree of correlation is for petal length and petal width. Okay. Correlation strength is little less for sepal width and petal width. Okay. Well, that these box plots are there also to show the distributions, and these different colors are there. Okay. Histograms are also there. Bar plots are also there. Correlations of those varieties are also shown, and I can include those in my report. A new slide will get added. New part will get added. This is not slide now. This is HTML. And very soon I will convert that to Word file. Plots, plots, and plots. Can you see the beauty? Hello.
Yes, sir.
I
Yes,
put
sir.
my,
Yes, sir. Yes,
I have,
Yes, sir.
yeah,
Yes,
and
sir.
I have put my case that R programming is very strong and not difficult to use. Now, the next part of our agenda that we want to see, installation of R programming. Demonstration of complete data analysis will not go in this session because we are going beyond 1 hour. And intro to R programming also will go in next session. Okay. Installation of R programming, I will show you. I will just close my workspace, my software, I will close. I will go here on Google. I have shared the links also with you. These instructions to install the software. I will open that. This will not be that pretty one. I'll close that. I'll just download and open that file. This is the file, a prettier one. I created this file using R programming only. HTML file using R. I don't know HTML, how to code HTML, but I did that. When you have this file, when you open this file in your browser, you'll see this link. When you click on that link, some file will get start downloading. Here that download has been started. That R version 4.3.2 is running, is getting downloaded, and it will take 16 seconds to get downloaded. Okay. Meanwhile, I will start another download of RStudio by clicking on this link. Clicking on this link. XML file does not appear to have any style information associated with. The document tree is shown below. Why that is showing, don't know. And I think you are also facing the same issue for that. This issue may be because of this thing. I will just copy the file, and that is because of the no space in between. I'll take this, copy this, and take that to your browser window and remove that too. Remove that too and run. Again, the same thing. XML download one studio.r electron Windows RStudio, this one. Why download is this link is not working? I will share the another link with you. I will share the link as part of email only. RStudio download, RStudio desktop, install RStudio. I will click on this and the file download has been started. I will copy the link address. I will share that link address with you. Hello.
Hello.
Yes, sir.
Yeah. I thought
Yes,
that
sir.
I left the meet. I will add that to here.
Yes, sir.
In inbox messages, I posted the link so that you can copy paste that link on your system and you can install from that. Whenever you require, you can get that. Or alternatively, you can go to Google, type in RStudio download, and you will get this POSIT site, RStudio desktop, and install RStudio. Here you will get for both. You can install R also from here. You can install RStudio from also here. Okay. When you get that file downloaded, open the download folder and click on R programming. That R 4.3.2 is R programming. You have to install that R programming first. This window will appear. Run that, and that installation will take some time. Next one already exists. I will not click that, but when I click on install, that installation will go on. My installation is already there. Therefore, I will not go for R installation. RStudio, I'll click on this. On any computer, you can download and install these files. There is no restriction. I'll just click in. Installation will go on. And I'm allowing it to get installed. It will take some time, and I'll have to go on clicking the next and next if it asks me. And believe me, these are softwares with very high ethics, very high moral values. Therefore, they will not ask you to install any other thing, not like Adobe. Have you tried to install Adobe? Adobe push McAfee with its installation. Here, R will not ask you to install any other thing. It will just install the things which you want to install. It will not force you to accept any other conditions. No, these peoples are peoples with very high integrity. The software is getting installed. Let it install. Very few minutes it will take. And when it installs, you have to just finish that and type in RStudio there. RStudio in Windows that Cortana it is called as. I'm working with Windows 10. On Windows 11 system, maybe a little different. Just type in your software name there, which you want to run RStudio, and spelling mistake is there, RStudio, and run that. Software will run.
Will it work with Windows 7?
For Windows 7, little other download file, other installation files are required for Windows 7.
Okay.
But
Okay.
that will be little difficult because some packages may not work with Windows 7.
Okay.
That old operating system, one thing I will just show you. Old are versions for Windows 7 are there. 64-bit, 32-bit, you have to find out how many bit system your computer is, and you have to download according to that. The new versions are not 32 bits. All those are 64 bits because all new laptops, all new operating systems are 64 bit. Okay. If you have 32 bit, then you can download for 32 bit. If you have 64 bit, you can download for 64 bit. And that previous releases of R, you can download this as per your requirement. Okay. All old versions are also possible. Now I'll go back. Download R 3.2.2 for this one. 3.2.2, I don't know, recent version is 4.2, but it's always good to have most recent version of R, most recent version of these free softwares, because they come up with too many advances. The older versions are not that helpful. Many of those packages may not work there. This is about installation. You can install that very easily on any system. No issue will be with that. Okay. Other things, installation of extensions and all that, I will show you as we go on in this workshop. In next sessions, I will show you other things also. Okay. Now I will just introduce you what I shared with you, the files, and which I'm going to share with you today. Share with the participants of the mails which I have. I will share with those that these files actually I shared with you. Experiment plant growth. This HTML file I shared with you. I will open this file to show you how that works. Summary table, distributions. In water, growth is this much. In 1.5 HCl, growth is this much. In 3 HCl, growth is this much. The growth according to light, the D is getting more light as compared to A. That growth is like this. Okay. Height of plant is more. Then bar plot, the distribution of water, HCl and HCl, these plants according to light. For E, where light is very high amount of light is available, height is more, plant height is more. But when that acid value increases, acidity of medium increases, that plant growth is little less. That according to acid also I have plotted that A, B, C, D, E. You can see here in E that when water is there, height is very high. That test I ran, ANOVA test I ran, and if you see here in ANOVA, you can see star here. This is significant. Acid has significant effect on growth. But that availability of light doesn't have any significant effect. You can see the difference here in the plot, but that difference is not statistically significant. And this is the description of ANOVA. The main effect of acid is statistically significant and large. The main effect of rho is statistically not significant and large, and all that. All this is about quality of that feed. That summary is there, characteristic p-value. For acid, significance is there. For rho, not significant. Pairwise differences are also there. B to A, no significant difference, no significant difference in any row. But for acid, that significant difference is there in 3% HCl and water. Significant difference is not there in 1.5% HCl and water, not there in 3 and 1.5% water. Significant difference is not there. But significant difference is there in HCl and water. This is the beauty. It is showing us that what these numbers mean. The other file which I shared with you is Puromycin experiment. That Puromycin experiment, I have to download that and run that. This Puromycin experiment is there. You can see that Puromycin treatment increases the enzyme activity. This is Michaelis-Menten curve of Puromycin experiment. And activity get increased when we treat the cells with Puromycin. Activity of that enzyme, glycosyl transferase, increases. Significant difference is there in between. The model is fitted, the Vmax is calculated, treated, untreated. Vmax of treated is higher. That Km of treated is also higher. We can find out what type of inhibition it is. We don't have to plot Lineweaver-Burke plot. We don't have to plot on graph. The people who are actually using the graphs till date are the people who are living in the era of 1950 or something. We are almost 70 years behind if we are using graph paper to plot our data. Softwares are available. We can imagine we have car, but still we are trying to crawl on the land. We have the car to travel a very long distance also, but we don't know how to drive the car. Therefore, we prefer walking, we prefer crawling. Just because we don't want to learn the car. Car is free. This car is not costly. It is free. But still, if you don't want to learn, then somebody wants to join. If you don't want to learn, then that's, I don't know what to call
And
it.
what about that ice hockey stick? We were having
Hello?
only 2 days on that. And last time I worked on the account was November. I guess November when I opened the budget just to gauge the performance. And I guess it hit around.
Okay. That's it for today. We can perform statistical analysis. That linear models also we can fit. We can fit classification models also. We can do anything with it. We can plot, we can graph, we
Excuse
can
me, sir.
plot figures, we can do anything. Hello? Yeah, you can ask the
So,
question.
For our programming, basically,
Maybe
there
after
is
15.
there is a need of having some kind of database beforehand. Is it true?
To learn or to use that for analysis.
Just like you showed, like you modifying graphs, making presentations, changing documents and all. That means you need to have some kind of data beforehand. So that's necessary.
Yeah. Yeah. If you don't have data, then you don't have to do analysis also.
So basically, it's about manipulating large amounts of data quickly for our convenience.
For small data also it works. I'll show you one experiment which my students actually carried out. That is, I asked my students to pipette out 1 ml volume and to see what is the accuracy of their pipetting. And this is the file, PDF file which I created of their analysis. That some noises are there. I actually get distracted when noises are there from the session. And don't know, this is why this is there. This file is little different. Pipette calibration experiment 2025. Okay, 2023 it is. This data is collected by my students. This year students. Dhanashri pipetted this much. Shivani pipetted this. I asked those to pipette 14 volumes. And 14 values were calculated here. 0.95 ml, 1.05 ml, 1 ml. Repeated measurements are there. I have collected this data from those students. I've converted that data to table. I have analyzed that data, summarized that data. This is the distribution of the data. This is the distribution of the data, not much visible, but here you can see that what is happening. This is data from my class. My students pipetted out the volumes, and you can see that Shubham is actually pipetting higher volumes consistently. And Nachiket is pipetting quite accurately, pipetting 1 ml accurately. That accuracy of Srushti is also very high, but for some volumes she did little mistakes. Little, but those are just little. For Shravani, she is consistently measuring lower volumes. Most of the students are doing quite pipetting with quite good accuracy. This is the local distribution. That Srushti, good accuracy. Shivani, good accuracy. Nachiket, good accuracy. And if I plot this accuracy along with their scores in exam, theory exam, they actually correlate. Nachiket, Srushti has quite good marks. Nachiket has quite good marks. Shivani has good marks. Shazia, I don't want my students to be here, but Shazia is not doing good in theory exam also because she is not serious about her quality. Okay. Bhakti is little cautious. She is consistently measuring at higher, but her accuracy is quite good, not much bad. Shubham consistently on higher side. Their marks actually correlate with their pipetting accuracy or pipetting seriousness. Okay. Many different plots are there to show the same thing. These are bar plots. Bar plots are not good to show these things, but still those bar plots with error bars are there. Then we'll go with the ANOVA. Student, there is no difference in the readings taken by the students. There is statistically no significant difference. If you see that pairwise one, very few students will show you the difference pairwise, and that difference, significant difference, almost not there. These numbers actually don't show much efficiency. No statistically significant difference is there in pipetting. This accuracy is less, Shubham and Dipali, because Shubham's readings are quite wavered. Shubham is very good at software and doesn't have much good practical hand because his orientation is not working practically. Okay. And another experiment which we will stop within few minutes. That's why my Explorer is working. Puromycin experiment. Search in R works. Just last demonstration. I actually love this system very much. Therefore, it's very difficult to stop. That polyphenol experiment I will show you. Here, my students actually did replicate measurement of tannin assay, polyphenol assay, to measure tannin content of food. And 3 students performed the experiment, Bhagyashree, Tanvi and Vaishnavi. And their readings are almost similar. No statistically significant difference is there. This is the ANOVA result, 0.97. No statistically significant difference. The readings are almost similar. The experiment is working quite beautifully. This is the calibration curve. This is equation. This is getting overlapped. I have to adjust it a little. And R square value is 0.95, almost linear. Most linear. These are error bars. We plot calibration curve, but we don't plot calibration curve with these error values. We don't plot calibration curve with this R square value in this Y, this equation. Okay. You can see the unknown values also plotted on the graph. Unknown values are plotted. The equation is there. Then R square value is also there. this is most suitable plot to show to my audience. And that these are the ANOVA results, that linear model results, and absorbance, significance of absorbance. Absorbance is actually quite significant. Correlation is quite significant, and p-value is almost 0. That I will not get these results by chance. These results are there because of the data, because of quality of the data. And that's it. Our own data also we can use, and this data, my students use this data, and this data will be somewhere here, polyphenol assay. This is not, this is the data which my students created. This is also not the complete data, polyphenol assay wide, and here actual readings are there. That's not opening here, that's opening. And these are the readings by Tanvi, Bhagyashree, and Vaishnavi. These readings I plotted. And that's a very relevant question. We can plot only when we have the data. We can analyze only when we have the data. Okay. Any other question for this session? Hello? Am I audible?
Yes, sir.
Yes, sir.
Okay. If no question is there, then we'll stop for this session. I will share some files with you. If you have installed RStudio, you can run those files in RStudio. You can see how those files are working. You can learn from those files because those files are tutorial files. You can copy paste code from the HTML file in R, and you can run that code. I will show you in next session how to run code, how to copy paste code from this HTML in R and run that. Okay. And the tutorial which I will share with you will be in HTML format. You just have to open RStudio, and type in the code there. That copy paste the code. I'm copying the code. I'm taking that code here, and that new file, R script, a new file will open. Here I will type the code and run the code. It will work. Type the code from the file, HTML file, it will work. Okay. Hello.
Yes, sir.
And we'll stop here for today.
Yes, sir.
I will share
Yes, sir.
the tutorials with you. If possible, go through the tutorials. Try to use R programming. If it's not possible, in next session I will help you. And tomorrow I will arrange a special session for installation of R programming, RStudio and R programming. And those people who have already installed may not join the meeting. It's not necessary for those to join the meeting. And those who want help to get those softwares installed will only join the meeting tomorrow. We'll stop here for today. Okay, I'll stop my screen presentation. And
Thank you, sir.
next meet tomorrow only for installation. The same link will work. That CYB, CHBC, GJC, this link will work for all these 5 sessions. Tomorrow's session will be extra bonus session for installation. Okay, those who want help for installation will join tomorrow's session. Others, no need to join. Okay, shall we stop here for today then?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
I'll stop recording.